You complete, tell fast. Completed?
Now, sir.
Okay. See the next one. Select the correct statement about the formula of moment of inertia in terms of mass m of the object and some of its distance parameters such as r, l. Different object must have different expression for moment of inertia. Is it correct? Different object must have different expression for moment of inertia. Hello?
हाँ सर, एक सेकेंड जस्ट.
Different object must have different moment of expression for moment of inertia. Is it correct or incorrect?
सर इनकरेक्ट है.
Different objects must have different expression for their moment of inertia. Incorrect, because कभी कभी तो ऑब्जेक्ट का सेम भी हो सकता है.
हाँ सर.
फिर बोला when rotating about their central axis, hollow right circular cones and a disc have same expression for moment of inertia.
ये वाला सर करेक्ट है
कैसे?
सर. क्योंकि ये वाला क्योंकि
क्यों?
सर क्योंकि उसमें नंबर मतलब कि कैसे सर वर्ड्स नहीं कलेक्ट कर पा रहा हूँ. समझ गया है पर
एक बार फॉर्मूला मालूम है तो ही समझेगा ना.
हाँ हाँ सर.
तो सर्कुलर कोन का फॉर्मूला ऊपर दिख रहा है आपको, mr²/2 हॉलो
हाँ.
वाला, और डिस्क का मैंने लिखा है mr²/2. आंसर बी इज करेक्ट. Next class, I want that first to by heart all the formulas of moment of inertia, which is given on page number 21 and 22 and 23. Hello? Hello? Next one. So correct answer is B. Chances are there we will write A as correct. A is clear correct नहीं, because they are telling must be. It is not necessary. Fourth. Textbook each and everything, if you are knowing, you will get full mark, because this time I feel they will not ask anything out of textbook. In a certain unit, radius of gyration of a disc about central and transverse axis, radius of gyration is root of 2.5. Its radius of gyration about central axis means passing through center. Radius of gyration about tangent in the plane, about tangent in the plane in same unit will. If this is disc, then this is transverse axis passing through center, and this is tangent in the plane. So to use the formula tangent in the plane, I should know this moment of inertia. Then only I can find moment of inertia of tangent in the plane, which is parallel to diameter. So I told you, remember, I diameter for disk or ring is IC by 2. So by parallel access theorem, I about this center C will be IO equals to, this is O, will be IC, that means I diameter plus MR square. I diameter is IC by 2 plus MR square. We want answer in terms of radius of gyration. So radius of gyration about tangent will be how much? Till this line, any doubt is there?
No.
Now this MR square for disk, what is IC? MR square by 2. So I'm multiplying by 2 and dividing by 2 to get my answer in terms of IC, because IC ka radius of gyration I know. So IO will be IC by 2 plus this is 2 times IC. So IO will be equals to 3 by 2 times 2 to the 4 1 5 by 2 times IC. IO means MKO square. IC is MKC square. Both side M we can cancel. Therefore, KO equals to root of 5 by 2 into KC. Root of 5 by 2 is 2.5 and KC is also root of 2.5. So KO equals to 2.5. Very, very important sum. Option B. Any doubt? Any of you are having doubt in this sum?
No.
Okay. हेलो, उसका आंसर किया है क्या? कल जो टेस्ट पेपर था 11th का लॉ ऑफ मोशन का, बनाया नहीं था ना? नहीं बनाया नहीं था। उसको बनाओ, चेक करना, सॉल्व करके देना, ऐसा मैंने बोला था। हाँ हाँ बराबर बराबर, करेक्ट करेक्ट, ठीक है ठीक है ठीक है, अभी बनाना होगा प्लीज। ठीक, हाँ बना दो, बना के मुझे भेजो।
Done.
At fifth. Consider following cases. A planet revolving in an elliptical orbit. A planet revolving in circular orbit. Principle of conservation of angular momentum comes in force in which of these? Only P, only Q, both P and Q, neither P nor Q. A planet is revolving in elliptical orbit, planet is revolving in circular orbit. Principle of conservation of angular momentum comes in force in which of the following cases? What is principle of conservation of momentum? When angular momentum acting on a system, when torque acting on a system is zero, then angular momentum is always conserved. Planet revolving in elliptical orbit, angular momentum is conserved. We know from law called as Kepler's law. Planets revolve in around sun in elliptical orbit. Aerial velocity remains constant. Therefore, angular momentum is constant. This we have done. अभी second बोल रहे हैं, if it is revolving in circular orbit, तो क्या? If it revolves in circular orbit or it revolves in elliptical orbit, its aerial velocity will be same. That means angular momentum is constant. Change in angular momentum will be zero. Hello?
हाँ सर.
दोनों का एंगुलर ऑप्शन दोनों राइट है. किधर दिया है? बोथ P and Q.
C.
That is C. Next question. A thin walled hollow cylinder is rolling down an inclination without slipping. At an instant, the ratio rotational, translation and total kinetic energy is in what ratio? What is rolling kinetic energy of hollow cylinder? Hollow cylinder means like ring. Rolling kinetic energy of ring equals to mv square. Rolling kinetic energy of disc equals to 3/4 mv square. Rolling kinetic energy of solid sphere is equals to 7/10 mv square. These three formulas you should know. So hollow cylinder is like ring. At instant, rotational kinetic energy will be half I omega square, which is half m r square into v square by r square. That means it will become half mv square rotational kinetic. And translation is also half mv square. Translational kinetic energy is half mv square for all the body. So this ratio is 1:1. Half mv square upon half mv square is 1:1. And rolling total kinetic energy is mv square. So what will be the required ratio? Rotational kinetic upon translation kinetic is 1/1. Then translation upon total will become half mv square upon mv square. So it will become 1:1:2. Right. Understood what I did? I just took ratio, nothing else. So 1:1:2 आ गया.
Done.
Done. Okay. Question number 2, I'm reading, and see whichever you don't know, we'll discuss. Why are curved roads banked? We have done. Do we need to bank road for two-wheeler? Explain. We have done. On what factor does the frequency of this also you should know? It is independent of some factor. Yes, mass of the ball. Why is it useful to define radius of gyration? Why it is useful to define radius of gyration? Right answer if you are not knowing. Write down. Why it is useful to define, question write down. Why it is useful to define radius of gyration? Radius of gyration is the measure of distribution of masses radius of gyration is the distribution of masses from the axis of rotation. Thus, by knowing radius of gyration, we get the idea of distribution of the mass. We get idea of distribution of mass. Fifth question is, a uniform disk and hollow right circular cone have same formula for their moment of inertia when rotating about their central axis. Why is it so? A uniform disk and hollow right circular cone have the same formula for their moment of inertia when rotating about their central axis. Why is it so? This is the question they have asked. Are you knowing why it is so? What is moment of inertia defined as? Hello? What is moment of inertia defined as? What is definition of moment of inertia? What is definition of moment of inertia you are not knowing? Write down. It is defined as sum of product of masses. It is defined as sum of product of masses and squares of is defined as sum of product of masses and squares of their distances from axis of rotation. It is defined as sum of product of masses and square of distance from the axis of rotation. Then write answer for this. A uniform disk and hollow right circular cone. Uniform disk and hollow right circular cone have same formula. Have same formula. Because both have same tendency to oppose the rotational motion. Both have same tendency to oppose rotational motion. Both have same tendency to oppose rotational motion. Third question, while driving along bank road, two-wheeler rider has to lean with the vertical. Why it is so? With what angle rider has to lean? Derive formula. This we have done. Using energy conservation, derive expression for minimum speed at different location. This also I have done. Discuss necessity of radius of gyration. We have done. State the condition under which theorem of parallel perpendicular. This also we know. Derive expression for related angular that relates angular momentum and angular velocity of rigid body. Angular momentum and angular velocity, that is L equals to I omega, we have done. Then torque we have done, law of conservation we have done, link between rotational kinetic energy we have done, drag we have done. Okay, this is question number 12. Somehow an ant is stuck to the rim of bicycle. Somehow an ant is stuck to the rim of bicycle whose diameter is 1 meter. Diameter of bicycle 1 meter. While the bicycle is on central stand, the wheel is set into rotation and it attains the frequency of 2 revolutions per second. In time 10 seconds with uniform angular acceleration. Calculate number of revolutions completed by the ant in this 10 seconds. Number of revolution of ant in 10 seconds. Time taken by it to complete revolution and the last complete revolution. Time taken by it for first revolution. Time for first revolution and time for last complete revolution. An ant is stuck to the rim while the cycle is on stand. The wheel is set into rotation and attains frequency of 2 revolutions per second in 10 seconds with uniform angular acceleration. Find the number of revolutions completed by the ant in these 10 seconds. So this is 2 revolutions per second in 10 seconds. That means this will give me omega at the end of 10 seconds. Initially omega 1 0, omega 2 is 2 pi f. That means 2 pi into 2 equals to 4 pi radian per second. Number of revolution means you can find theta. Once you know theta, you can find number of revolution is theta by 2 pi. 2 pi radian means 1 revolution. So theta radian, how many revolution? It will be theta upon 2 pi revolution. So first I am finding formula from this. Theta equals to omega 1 t plus half alpha t square. So theta is 0 into t plus half alpha is omega 2 minus omega 1 upon t into t square. So that will become theta equal to half omega 2 minus omega 1 t square upon t, only t will remain, 1 t will get cancelled. So half of 4 pi minus 0 into time 10. So therefore theta is half of 4 pi into 10. So theta is 20 pi radian. So number of revolution is theta upon 2 pi, which is 20 pi upon 2 pi equals to 10. First one clear? First sum? Hello? First sum is clear with you?
Yes, sir.
So common mistake here will write f 2 revolution per second. So तो 10 सेकेंड गलती से 20 लिखने का चांस है। अब ये बोला है 2 रिवॉल्यूशन पर सेकेंड 10 सेकेंड में हुआ, because alpha is given means it is non-UCM. So from frequency get omega 2 and then get theta and then divided by 2 pi. Yes, try first sum. हाँ बोलिए, कहाँ से? इसके पहले तो 2-3 बार आपने फोन किया था, मैंने बोला मुझे कुछ इंटरेस्ट नहीं, फिर भी बार बार कॉल करते हो। First part done. Then we want time in first second, time taken for last revolution. Yes, completed. This sum you have completed or not so far? Hello?
Yes, sir, done.
Then we want what is the time taken for first complete revolution and last complete revolution. Time taken for first complete revolution and last means 10th. What is formula for distance covered during nth second? Are you knowing this formula? Q plus half a 2n minus 1. This is in straight line motion formula. Distance covered during nth second is u plus half a 2n minus 1. So this theta during nth second will be omega 1 plus half alpha into 2n minus 1. Please write this formula for distance covered during nth second. Distance covered during nth second.